Are we live? Are we live? Hold up. Let's see. Select stream. I'm seeing it. I am seeing it. All right, nice. We need to lock in, and I need to study neuroanatomy to do well in my class. So nothing too deep. Quite literally just studying. Why am I streaming this? I don't know. Why not? Okay. Yeah, so I have the slides pulled up here. I'm gonna do a quick recap of slide 2 before I go on to brainstem. I think that would be a good idea. Yeah, let's do that first. So yeah, let's do that first. I think talking out loud through this would be a good idea. Maybe, maybe not. Let's also go through some of the questions that I had. Was it spinal cord? Yeah, spinal cord 2, brainstem 1. I want that to be, well, that's fine. So that's the recent one, spinal cord 2. What motor system controls the limbs? What controls the trunk? Can I do that? Let's do this first. Yeah. Okay, so the lateral motor system controls the limbs, and that is located on the obviously on the lateral portions of the spinal cord, not on the medial portion, which is weird because the medial portion is further up front. So lateral portion controls the limbs, the medial portion controls the trunk, so torso. What's the difference between gray matter and white matter in the spinal cord? What is the difference between gray matter and white matter in the spinal cord? I want to say that gray matter may control the motor systems. No, it doesn't. What is the difference? So this is the gray matter. The gray matter controls the horns, which is part of the this is a good review. I know that nerves need to go through the gray matter before they access the white matter. So somatosensory synapses, they need to go through the gray matter before they go to the white matter. What about with motor systems? Do they need to go through the gray matter before white? They go in ventrally, right? So this is the motor systems. Motor systems go through ventrally. Do they go through the gray matter? Well, let's think about this. So the motor systems go from the brain down. So I would say so yes. And we can fact check this. So here, yeah, they go through. So I would say difference between gray matter and white matter. Gray matter contains the horns within the spinal cord, and those need to be accessed before the white matter is accessed through the motor systems or the somatosensory systems or pathways. Somatosensory pathways. The somatosensory neurons, I feel like that should be called pathways. Do somatosensory These are tracks. Is the pathway or tract? Mm. Okay, well, the somatosensory neurons enter the spinal cord proximally or distally. They enter. They enter. Distally. I feel like that terminology is wrong. Distally is further away. Proximally is closer. So they're both distal because they're both on the edges. Further away from point of attachment. So yeah, this is wrong. They're both distally because they're both away from attachment. So I think the better terminology would be dorsally or ventrally. So somatosensory neurons enter dorsally, motor neurons enter ventrally. I don't know if I should say dorsally. Inferiorly, dorsally. I think dorsally is right. Dorsally ventrally. Striate muscles are muscles that are. I know they're on the organs. They're a type of muscle. It's based off the way they look, because they look like they have striations. Yeah, striped. Okay, so I was right. So they have striations under a microscope. Why do lower motor neurons synapse to striate muscles? I don't want this open yet. Well, I know that lower motor neurons synapses striate muscles so they can contract. Okay, I see. So lower motor neurons synapse on striate motor neurons. Lower motor neurons synapse to striate muscles. I want this open. Oh yeah, because we're talking about the motor pathways, not the somatosensory. Yeah. So the upper motor neurons access the dorsal horns, and then the lower motor neurons from there go from the dorsal horns to the striate muscles. What is the difference between upper motor neurons and lower motor neurons? Upper motor neurons access the dorsal horns first to then communicate with the lower motor neurons. How are they related? Yeah, upper motor neurons synapse on lower motor neurons synapse on the muscles. Do upper motor neurons receive signals and send signals? No, they do not. They send signals. They do not receive signals. What about lower motor neurons? Lower motor neurons, I believe, only send signals as well. And they both only send signals. What happens if a lower motor neuron is lesioned? Well, then a patient, or yeah, they would be a patient at that point. They would want to move their body. The upper motor neuron would send that synapse, but the lower motor neuron would not receive that, so they would not actually be able to move. What are symptoms of lower motor neuron syndrome? Inability to move. What are they feel like moving? Okay, there's a lot more to that. Okay, lessened reflexes. They're slower. Yeah, fibrillation, Fasciculations. Fasciculations. How are the fibrillations low motor neuron syndrome? If the nervous lesion is damaged, a synapse should not be possible since the pathway of transmission does not exist, right? Yes, correct. Although it is more sensitive to acetylcholine because I think if it's lesioned here, the acetylcholine receptors spread out throughout the muscle, and then they become more sensitive to chemical changes. What is the main tract upper motor neurons run through? Okay. What is the main tract upper motor neurons run through to access lower motor neurons in the lateral motor system? Okay, so this is the part where it's kind of tricky. So let's look at these before we get into that. Okay, so we're talking about the motor system. So this is a corticospinal tract. The medial motor system not only goes through the corticospinal tract, but the vestibular and reticulospinal. What does vestibular and reticular mean then? Balance. Okay, that makes sense. Okay, so it goes to the vestibulospinal because of balance, corticospinal because of movement, and reticulospinal is I'm assuming muscle tone. Is a contraction of the muscles, right? Yeah. So muscle tone. What is that one? Muscle tone. Balance. Vestibulospinal is balance. Reticulospinal is muscle tone. So the medial motor system goes through corticospinal, vestibulospinal, and reticulospinal. Reticulospinal is balance. And reticulospinal is tone. Vestibulospinal is balance. Right. Vestibular is balance. Yep. And then so balance, tone, movement in the trunk, and then it's just movement. Okay, got it. Let's see. The lateral motor system, they go through the corticospinal tract. If there's a lesion of the vertebrae in the lateral motor system, if there's a lesion of the vertebrae in the lateral motor system, okay, what is the damage? Well, in the there's a lesion in the lateral motor system, they would be unable to move their legs. Even though if they were trying to send signals, yeah, they would be unable to move their legs, I believe. Someone is lifting something outside of the crane. Okay. We just did that. And then we have, okay. Should I have this in? Can I move this out somewhere? Okay, maybe I'll just have that there. There we go. Okay. No. Okay. Just had to set something up in OPS. Okay, so the lateral motor system is corticospinal, the medial motor system is vestibulospinal, reticulospinal, corticospinal. Vestibulospinal is in balance, reticulospinal is in muscle tone. Okay. What is the difference between ipsilateral and contralateral? Ipsilateral is of the same level, contralateral is of different, is of the opposite side. There's lesion, yeah, we talked about that, their legs would not be able to be moved. Where? It would be at the level of the damage. So it's not just in legs. So they would be unable to move past the point of damage of their limbs. What type of information do the fibers in the lateral transmit? What type of information? Information in relation to movement? I don't know this. I don't know what it's asking. Yeah, ipsilateral to the region. What type of information? I feel like I'm right. Just information in relation to movement. Medial motor system is the corticospinal tract, which goes to the lateral motor system. Same tract goes to the medial motor system. No, they're separate. One is anterior, one is posterior. What is the name of the two main tracts? What is the name of the main tract? Ultramotor. What is the name of the main tract? Upper motor neurons run through to access the medial motor system. Corticospinal tract. This is not the corticospinal tract. I'm assuming it's a corticospinal tract. Okay, anyways. What are the two pathways to upper medial motor system? Vestibulospinal, reticulospinal type of information in the middle. In the corticospinal tract, it's in relation to movement. Yeah, movement of the limbs. But if you want to go to the vestibulospinal, it is in balance, and the reticulospinal is in muscle tone. So now we're going to go into somatosensory. So this is all motor. So maybe I want to do another header here called motor. Actually, no, this is all motor. So now we're going on to sensory. So I want to do this review, and then I'm going to move on to the other one. What tracks ascend and what tracks descend? How are they different? Oh gosh. somatosensory tracts ascend to the brain. Motor system tracts descend from the brain because the motor systems are going to move somehow. Sensory systems are what send the signals to the brain. How are upper motor neurons and lower motor? I should know the tracks though. It's come to my attention that I should probably mention. So did I say tract? What are two pathways? Okay. Main tract. Okay. Okay. Yeah, I did ask for the tracks. So I now want to go to this somatosensory tracts and make sure I understand those. Let's go to the bottom. Okay. Spinothalamic, spinocerebellar, cerebellar, and medial lemniscus. So because that's dorsal medial lemniscus. Okay. Okay. So there's three different. Okay. No. Okay. Okay. So the spinothalamic tract is involved in pain and temperature. The spinocerebellar tract is involved in motor coordination. Spinothalamic, spinocerebellar. Okay, so those are tract and the system. So the spinothalamic tract is involved with the anterolateral system. The spinothalamic anterolateral. Spinocerebellar tract is involved in the. There's anterolateral, then there's what? Okay, it's spinocerebellar system. Okay, that's fun. Then the dorsal column system is involved in proprioception, and that system is, or the tract for that is called the dorsal column system tract. It's called the medial lemniscus. Yep. Okay. Dorsal column, medial lemniscus, spinothalamic, that's for pain and temperature, and that is going to be involved in the anterolateral system. Then we have the spinothalamic. Then what is the spinothalamic? Spinocerebellar. That's going to be involved in fine motor coordination, and that's going to be for the spinocerebellar system. Got it. Okay. What else? Dude, I'm so steady, bro. I'm so steady. Okay, let's answer the questions. What tracks ascend and what tracks descend? Somatosensory tracks ascend. What tracks descend? How are they different? One is for motor, one is for sensory. How are upper motor and lower motor? What? For receptors receive information, the motor neurons are for transmitting information. Those are very different. So 3 ascending tracks and their function. 3 ascending tracks. The tracks. So the medial lemniscus is for the dorsal column system. I'll just hide this so it doesn't look like I'm looking at it. Yeah, the medial lemniscus is for the dorsal column system. The anterolateral system is for the spinothalamic tract, involved in pain and temperature, and the spinocerebellar tract is for the spinocerebellar system, involved in fine motor coordination. At where do they ascend to? Ooh. So I know two. Okay, I'm gonna take a wild guess. Spinocerebellar is for the cerebellum. Dorsal root for the dorsal column system. Don't know. Spinothalamic thalamus. This is also a thalamus. So, oh gosh. So this is for the thalamus. Spinothalamic, which is for the anterolateral, is also for the thalamus, right? Somatosensory cortex. Cerebellum. Where's the somatosensory cortex? So I'm hoping that this is in the thalamus. It's not in the thalamus at all. Okay, so the spinothalamic tract goes to spinal thalamus. Is that right? Okay. Okay. Anterolateral spinothalamic tract. Spinothalamic tract goes to spinal thalamus. Nope. Okay. So the spinothalamic tract is for the anterolateral system involved in pain and temperature and goes through the somatosensory cortex. We have the dorsal column system, which uses the medial lemniscus tract. Yeah, medial lemniscus tract, and that goes to the somatosensory cortices via the thalamus. So both of those go to the somatosensory cortex, and then the anterolateral system. Nope, that's what we just did. And then there's the spinocerebellar system, which uses the spinocerebellar tract, and that goes to cerebellum, obviously. Okay, so there's cerebellum, and then there's the somatosensory cortex. So somatosensory cortex. I want this one to be above, honestly. Yeah, because this uses the spinothalamic tract. Somatosensory. No. Oh, it's this one. It is almost in the right order. Legs, trunk, not trunk. I think it's upper torso. It's like horn shaped. This is cerebellum, but I think it's contralateral. Cross. Anterolateral, that is for the spinal thalamic tract, which goes to the somatosensory cortex, which is contralateral. So both sides. So anterolateral system for pain and temperatures both sides. The dorsal column system for proprioceptions both sides. That means the spinocerebellar tract. Is that for... Okay. Is this... So cerebellum is ipsilateral. Somatosensory cortex is contralateral. Okay. And spinocerebellar tract is involved in fine motor control. Okay, that was a good amount of information. I think it's a... How much time was that? 30 minutes. I think it's a good pausing point. Yeah, a good pausing point before I go into more information. So let's go to brainstem. No, let's stay here. And let's just do... be back in 5 minutes. Okay, I'll be back. Okay, dokie. Lock back in, lock back in. Okay, so what do you do now? We just did the spinal cord. To recap, we just went over the fact that the. Okay, dokie. Oh my gosh, this is playing in the background. That's crazy. We just went over the fact that the anterior lateral system connects to the spinal thalamic tract involved in pain and temperature. Spinal thalamic tract connects to the somatosensory cortex. This is also true for the dorsal column dorsal column system, which connects to the or uses the medial lemniscus, which goes to the it goes to the same somatosensory cortex. However, for the spinocerebellar tract, which is involved in fine motor control, or the dorsal column system is involved in proprioception, spinothalamic tract or spinocerebellar tract is involved in fine motor control, which goes to the cerebellum. That one, let me double check on. I should double check. Cerebellum. Oh, the cerebellum is ipsilateral, meaning one side, whereas the other two systems in the spinothalamic tract, in the somatosensory cortex, are contralateral. So things involving fine motor control are isolated to either side. We also went over the fact that the lateral motor system, where does that, what did we talk about for that? What did we talk about for that? I'm sure I have it listed here. Lateral motor system, the tracts of the lateral motor system. What tract is that? So there's lateral and medial. The lateral motor system uses the corticospinal tract. Yes. The lateral motor system uses the corticospinal tract, whereas the medial motor system uses not only the corticospinal tract, but also the vestibulospinal and reticulospinal. The corticospinal tract is involved in motor control, voluntary movement, and the vestibulospinal tract is involved. Corticospinal tract, but the vestibulospinal tract is involved in balance. The reticulospinal tract is involved in there's balance, and then what's the other one? Reticular movement. What is that? What is that? Reticulospinal tract. Muscle tone. Okay, so vestibulospinal tract is involved in balance, reticulospinal tract is involved in muscle tone, and the corticospinal tract is involved in voluntary movement. Oh, and obviously medial is for trunk, lateral is for the limbs. Okay, I think that's enough of that. Now, let's get on to the other slides. Let's get on to these. Let's go ahead and download these. I want to download them. I don't know what that is. Download. Ooh. Do we already have these slides? These are for other assignments, if you're wondering. So we have brainstem slides. So let's just do rename. Brainstem 1. Let's move that over to slides. I think that's good. What is happening here? Let's do that, delete that, and then no, I think we can, I think we can go ahead and move that over here. sensory cortex connects to the two systems. What are the systems? Anterolateral, dorsal column system. It's always the last one that I forget. Anterolateral, dorsal column, spinothalamic. No, spinocerebellar. Spinocerebellar system, right? Yeah, spinocerebellar system. Okay, now that we've done that good review, let's go to brainstem 1, yep. Yay. I wonder if I can annotate in this. Nope, I guess I can't, which is fine. I want to go ahead and push my changes up. So I'm going to do that really quick. What is it? Okay, so it's okay. I want to see these documents. Obsidian. Wait, you know what I can do? I'm just hide my display caps really quick. Just want to make sure. CD documents. You know what? I guess we're not going to CD into any documents. Okay. I just want to push these changes. I just don't think anything's going to show up, but in the off chance that something bad does show up. So, C documents. Documents, I'm going to go to Obsidian. Git add dot git commit. What did we do? We review. Okay, changes have been pushed, so we can resume the display capture. I just have this connected to Git, so that way we can have the changes. This is quite a beefy lecture. I'm not excited. Why? I don't know. We'll find out. Okay. I need an orange. Okay. What are the levels of the brainstem? I think so. Yeah, there's landmarks. So let's try answering these questions. What are the levels of the brainstem? I don't know. But I'm seeing this. I'm seeing some junctions. Seeing 4 junctions, but only 3 here. This is not being shown. I'm sure it's further up. Yep. Okay. So. There's the midbrain's pons and medulla. Above the midbrain, let's follow this. Above the midbrain is the midbrain diencephalic junction because it's between the midbrain and the diencephalon. Then I'm assuming if that's the case, midbrain diencephalic junction, there's a pons midbrain junction. No, it's called the ponto mesencephalic. Mesencephalic. What? 1 second. pontomesencephalic. Midbrain, diencephalon, ponto, because it's between the pons and the midbrain. I'm seeing the pon. I don't see the encephalic. Okay, anyways, pontomesencephalic, pon. So we have the midbrain diencephalon junction, diencephalic junction, pontomesencephalic junction. Then we have between these two, pontomesencephalic junction, medulla pons junction, pontomedullary junction. So anything that starts with the pons always comes first. So there's what are the 4 levels of the brainstem? So we have the midbrain diencephalic junction, pontomesencephalic junction, pontomedullary junction, pons medulla, and then there's after the medulla there's one more from the spinal cord to the medulla. So it's cervicomedullary junction. Okay, I understand that. So there's the 4 levels. What are the junctions in the brainstem? Huh? Okay. There's 4 levels. There's 4 junctions. We just went over the junctions. These are the 4 levels: midbrain, pons, medulla, spinal cord. Why are there junctions in the brainstem? Labeling. That's true. Let's ask questions. It doesn't really describe why. It just says they're needed for a function, obviously. Oh, I want to watch this. I'm going to save that for later. Okay. Okay, so allows for communication between the different levels of the brain. Okay, so it's just for communication between the different areas of the brainstem. Fine, perfect. Okay, then let us continue. What is the function of the midbrain? Okay, so this is what we need. So the midbrain reflexes. Pons is movement, midbrain is reflexes, medulla is basic vitals. So we have reflexes, movement and sensation, and basic vitals. Okay, let's move on. Between the cerebellum and rest of the central nervous system. I feel that doesn't really explain why. The eyes look funny. Okay, so it's just the primary, or is one of the first areas in which the cerebrum, no, not you, in which the cerebrum connects to the central nervous system. So large volume of traffic. Okay. Let's move on. So ventral view and dorsal view. Okay. Did I label this correctly then? Yeah, I did. So ventral is, yeah, okay, that makes sense. So I'm seeing that ventral view, midbrain, pons, medulla. We're seeing the mammillary bodies from the hypothalamus. So I remember in class you mentioned that this is cut off. Okay, cerebral peduncles, cerebral peduncle. We have the olive, two olives, pyramids, and the decussation of pyramids. I remember that decussation is because it's where the various fibers merge into one it's where they all cross. So rather than them all going down, they cross over each other and mix together, and I believe that's why there's less of a separation here. Hopefully I'm right. Why are the tracts separated in the medulla? For what I just said, I guess it's not super descriptive. Why are the tracts separated in the medulla? Let's see what good old AI gives us. Okay, so they're separated just to ensure that they're organized in the correct areas. Not everything has to have a complex explanation. They're separated so they're better organized from their respective areas. Not too bad. So the pyramid and olives have cleared separation, I'm seeing. And that obviously goes away at the decussation of the pyramid. Okay. Okay. Crus cerebri. I don't know what that is. Oh, that's the cerebral peduncle. So then I'll do that here. What is another name for the cerebellar peduncles? What happens to those neurons, contralateral neurons? I just mentioned that. Why are they separated? One of the names of the cerebellar peduncles, not peduncles. Another name is the crus cerebri. What nerves of the dorsal column are visible in the medulla? What nerves are visible here? I don't know. Perhaps we'll find out here. Ah, yes. Fasciculus gracilis and fasciculus conatus. Gracilis is the one involved in the legs, somatosensory nerves within the legs, and conatus is involved in the somatosensory nerves in the upper torso, I believe. Details of the brainstem. So I think we should separate this further into details of the brainstem. Details of the brainstem, and then let's do ventral view. Then let's do dorsal view. Maybe you can indent those. Maybe I can't. Thought that was indented properly. Okay. We answered this. So I'm seeing a lot more structures whenever you look in the dorsal view of the pons. Superior inferior colliculus showed up, as well as the thalamus, or a portion of the thalamus. Okay. So a bit more on the top, most in the middle, few in the bottom. Okay. So superior and middle cerebellar peduncle. Huh. Is this a start of the cerebellar peduncles? A little lost on where they begin and end. Okay. It's a little confusing. Okay, so we have the superior cerebral peduncle, middle cerebral peduncle, floor of the fourth ventricle, sorry, yep, that makes sense. And then inferior cerebellar peduncle. Okay, superior, middle, inferior, floor of the fourth ventricle, superior, inferior colliculus, thalamus. Not too bad. Not too bad. So maybe a good question here is, I guess this just is anatomy, so. No, my mic almost fell. What are the four pons? Maybe we can do the same thing for midbrain. So we went from having 2 to 3. And then we'll do the same for medulla. Here we have just two. What are the two? Okay. What else? Then we have the lateral view. So superior and inferior colliculus, that's not different. Crus cerebri, not different. Middle cerebral peduncle, this makes a lot more sense. So it's going up here. Okay. So we have the cerebral peduncle and the cerebellar peduncle. Got it. That's a good question to ask. So in form, we see that the cerebellar peduncles are typically visible only laterally or dorsally, whereas the cerebral peduncle is visible ventrally. Cerebellar is only dorsolateral. Cerebellar seems to have a lot more components. It seems to have three: the superior, inferior, and medial cerebellar peduncle. Doesn't seem to have just one, whereas the doesn't seem to have another one, whereas the cerebral peduncle, also named the crus cerebri, it's just one or two, I guess you can see in the front. Yeah. And function, though, I don't know. We'll find out. I assume we'll find out. Function of the olive. I hope to have a decent grasp of what's going on here. Not too much as to the memorization of it, because I just want to understand what's going on first. Now we go into recognizing cross sections. Okay. So maybe we'll do another one here called cross sections, which is pretty different. So hearing brainstem details. Okay. What are the sectors of the brainstem? Tectum. Okay, well, we have to be careful here because there's a brainstem, and in the brainstem there's the midbrain, pons, and medulla. So what are the sectors of the midbrain? So maybe let's start with levels, right? Maybe we should start with that. Okay, let's do this. What if we do levels? And in addition to levels, what happened? Okay, we'll do levels. We'll do levels dash midbrain levels dash pons level dash medulla. I think that's a good one to go on. What else? We have the features that are always visible. We have a note for myself here. Okay. Features that are always visible. Reticular formation, which is used in the anterior lateral, no, the motor, medial motor cortex, medial motor system. Oh gosh. Yeah, medial motor system. Reticular cranial. What? Okay, there's a dorsal column system, okay. Spinothalamic tract, which makes sense. But then we have the spinocerebellar tract. But we don't have the spinocerebellar tract, we have the corticospinal tract. So there's just a whole tract missing, and I'm kind of confused on that now. But besides that, okay, there's a few tracts missing. Don't know why. I do know this is what we're starting off with. So we're going to go off of sectors in the brainstem. There's a tectum, which is dorsal to the ventricle. Makes sense. Tegmentum basis. Maybe we'll do this as a question. I guess here we're not really trying to get into those, though. We're just trying to memorize it. Oh, whoa, 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 what did I just do there? The equal sign is kind of nice. This is how to identify the different levels. Levels of the midbrain, so midbrain, pons, medulla, are the cross sections. So we need to find the tectum. Tectum is up here. So this looks far below. Tectum would be over here. So here I'm looking for tectum, reticular formation, white matter tracts, cranial nerve nuclei. I think I can get rid of this. Okay, reticular formation. Where did we talk about that? Okay, reticular formation. I should ask, where's the reticular formation? Oh my gosh. Okay, that's nice. Some features. You can see the upper motor neuron. So I need to remember. So sectors are different than features. So these are features. So tectum is a sector, right? Yes, tectum is a sector. So we should do what features present at all levels, and then sectors, because these are sectors, yes. Okay, so this is a feature. So cranial nerve is a feature. White matter tracts is a function or sector. Reticular formation is a feature. So feature, sector, feature. Tectum is definitely a sector. So, okay, so they're alternating, which is fine. So we should do, that's fine. I thought the one that was it reticulospinal tract for the for the medial motor system. I think it was reticulospinal. Yeah, it is reticulospinal. So I was in balance. Okay. So I'm assuming this is related something with balance. Stone? No, it was vestibulo for balance. Vestibulo might have been for balance. Balance. Yeah, reticulospinal has always been tone. My bad. What does reticular mean? Not like. I think this is a bad question. Nah. There's two formations. So let me go in the tracks. So things that are always visible, the cross section, some small details of the midbrain, and the introduction to what everything looks like. Okay. What tracks are... dorsal, spinal thalamic. Okay, and then they left out the spinocerebellar tract, right? Yeah, spinocerebellar tract. Because apparently it's not visible, so just one of the motor tracts and the two out of the three somatosensory tracts. One of the motor tracts, 2 out of 3 somatosensory tracts. Yep. Okay, I think that's a good portion done. You got a brief, a good level of understanding of what's going on in these slides. I think I'll get some more details later. I think that's a good place to stop though. Okay, bye.